Hello, so in today's class, we'll begin with one more proposition. So I'm not giving the proof of this, only the proposition. So this gives 5 equivalent conditions, and these conditions can be used to show that a given set E is measurable. So let us look at the proposition. So let E be a given set, then the following 5 propositions are equivalent. And the following 5 statements are equivalent. So the first statement is E is measurable. So non equivalent statement. So this statements can be used to show that given that E is measurable. So given epsilon greater than 0, there exists an open set O containing E such that m star of O minus E is less than epsilon. So if there exists an open set O containing E such that m star of O minus E is less than epsilon, then in that case the set E is measurable. And again the next result is using a closed set. So given epsilon greater than 0, there exists a closed set F which contains E, F contained in E such that m star of E minus F is less than epsilon. So if we can find a closed set F such that for given epsilon greater than 0, if m star of E minus F is less than epsilon, then in that case again E is measurable. So that is the second condition. Then the fourth statement is there exists. So if there exists a G delta set, so G delta set G such that, so by G delta we say that capital G is a G delta set if G can be expressed as a countable intersection of open sets. So G will be equal to some countable intersection of open sets. So that is the meaning of a G delta set. So if there exists a G delta set G such that E is contained in G and m star of G minus E is equal to 0, then in that case E will be measurable. And the last statement is, so there exists an F delta set F such that F is a subset of E and m star of E minus F is equal to 0, and in that case again E is measurable. Now by an F delta set you mean that is a countable intersection, a countable union of closed sets. So it's a countable union of closed sets. G delta set എന്ന് പറഞ്ഞാൽ sorry this F delta അല്ല F sigma use ചെയ്യുന്ന notation. So that is an F sigma set. By an F sigma set you mean that's a countable union of closed sets, and G delta set is that is a countable intersection of open sets. So if these 4 conditions hold, then this can be used to show that a given set E is measurable. Now let us look at few problems. So the first problem is let sequence Ei be a sequence of disjoint measurable sets and A be any set. Then we need to prove that m star of A intersection union 1 to infinity Ei that is equal to summation 1 to infinity n star of intersection En. So let us look at the proof. Now, so sequence Ei is a sequence of disjoint measurable sets. So if you take union 1 to infinity Ei, so that contains union 1 to n Ei for all n. So union 1 to infinity Ei contains union 1 to n Ei. So that implies if you take A intersection union 1 to infinity Ei that contains A intersection union 1 to n Ei for all. Now, by the property of n star, so if you have A contained in B, then n star of A will be greater than or equal to n star of B. So, n star has this property. So therefore, n star of A intersection union 1 to infinity Ei that will be greater than or equal to n star of A intersection union 1 to n Ei. Now, this will be equal to n star of, so this can be written as union 1 to n, so this is union 1 to n വരുവിടെ. So this is union 1 to n A intersection Ei. So this is n star of union 1 to n A intersection Ei. Now this will be equal to summation 1 to n star of A intersection E. Okay. Now this is true for all n. So therefore this must also hold when n tends to infinity. So this is true for all n. So therefore it is true as n approaches to infinity. Now let us take limit n tends to infinity on both sides. So on the right side you are going to get so n star of A intersection union 1 to infinity Ei that will be greater than or equal to summation 1 to infinity n star of A intersection Ei. So let us call this as equation 1, and now if you take n star of A intersection union 1 to infinity Ei that can be written as n star of union 1 to infinity A intersection Ei. Now by the subadditivity property of by countable subadditivity, so this will be less than or equal to summation n star of so here you will get A intersection Ei, so where I varies from 1 to infinity. So call this expression 2. So from 1 and 2, so we will get n star of A intersection union 1 to infinity Ei that will be equal to summation 1 to infinity n star of A intersection Ei. So that completes the problem is give an example of a decreasing sequence, sequence En of measurable sets with intersection 1 to infinity and En equal to 5 and m of En equal to infinity for all n. So we need to find the decreasing sequence of measurable sets. അപ്പോൾ നമ്മുടെ sequence എടുക്കുന്ന sets decreasing ആയിരിക്കണം, measurable ആയിരിക്കണം. Their intersection must be equal to 5 and measure of each En must be equal to infinity. So let me define En to be, so let En equal to the open interval n to infinity for all n belongs to n. So the sequence is clearly decreasing. അപ്പോൾ നമ്മൾ 1 infinity എടുത്തു കഴിഞ്ഞാൽ 1 infinity contains 2 infinity. So this contains P infinity. So that is E1 contains E2, contains E3, so on. So therefore the sequence En is decreasing, and again sequence each En is an interval. Oro En an interval aanu. So Ens are intervals, so they are open intervals. So that implies each En is measurable. അപ്പോൾ നമ്മുടെ ആ കണ്ടീഷനും നമുക്ക് കിട്ടി. So decreasing ആണ്, measurable ആണ്. Now if you take m of En will be m of that is set n to infinity. So this will be equal to length of n infinity. So that is equal to infinity. The measure of En is infinity. Now it remains to show that intersection 1 to infinity En is equal to 5. Now if x belongs to 1 to infinity En, that means x belongs to En for all n. So that means x belongs to n infinity for all n. So that means x is greater than n for all n. So this is not possible for, so x must be greater than any n where n is a natural number. So which is not possible. So therefore intersection must be equal to 5. So therefore this is not possible. That implies intersection 1 to infinity En must be equal to the empty set. So that completes the solution. If E is measurable, then we need to prove that the set E plus Y is measurable, and measure of the level measure of E plus Y is equal to level measure of E. So we need to show that m of E plus Y is equal to m of E. So this gives that if E is a measurable set, then it is translation invariant under the level measure. So let us look at the proof. അപ്പോൾ നമുക്ക് E measurable ആണെന്ന് തന്നിട്ടുണ്ട്. Now we need to show that E plus Y is measurable. അത് നമ്മൾ ലാസ്റ്റ് പ്രപ്പോസിഷനിൽ കണ്ട റിസൾട്ട് ആണ് നമ്മൾ യൂസ് ചെയ്യുന്നത്. So we can find an open set which contains E such that m star of O minus E is less than epsilon if E is measurable. So let us look at the proof. So the proof is as follows. So since E is measurable, so given epsilon greater than 0, there exists an open set O such that so O contains E and m star of O minus E is less than epsilon. So let us call this as equation result 1. Now നമ്മൾ O open set ആണെങ്കിൽ O can be expressed as union of open intervals. So O will be equal to union 1 to infinity In. അങ്ങനെയാണെങ്കിൽ O plus Y will be equal to 1 to infinity In plus Y. അപ്പോൾ നമുക്ക് റിയൽ ഒരു ഓപ്പൺ ഇന്റർവൽ ഉണ്ടെങ്കിൽ so if you translate it, the interval remains open. Okay, so O plus Y will be union 1 to infinity In plus Y. Now since In is an open interval, so again under translation the nature of the interval does not change. So In plus Y is also open. So In plus Y will be an open interval. So O plus Y can be expressed as a union of open intervals. So therefore, so if the set can be expressed as union of open intervals will be again open. Okay, so therefore O plus Y is an open set. So O plus Y is an open set. Now നമുക്ക് O plus Y വരുന്ന പോലെ we will construct this result. E plus Y ഉം O plus Y ഉം വരുന്ന പോലെ നമ്മൾ if you can obtain a result of this form, then we can conclude that the given set is measurable. So let us show a result of this form. So therefore O plus y